And welcome back to Unplugged with Mike here at WiseSlice 2020. So the past few days we've looked at two different activities that would enable you to basically either decompose larger tasks into smaller tasks, which is critical to algorithmic thinking. And then the next day um, we actually looked at the ability to create some nonlinear narratives. So really testing out your ability to understand how to do breakdown of these larger steps, but includes conditional logic within it as well. So today we're actually going to start looking at representation of information. And this is actually quite challenging for a lot of students, obviously, especially when you start talking about the number system. So we're going to actually approach this from hopefully a graphical perspective that gives some students some options then in terms of how you translate it. So let's get started. All right, so I'm going to be really clear here. I am not doing the motivation piece or the context building. I really think that you can find ways that you can fit this in. I'm going to just present I'll say the activity portion, and I think you can frame that in a way that makes sense for you in your class and your students or your learners. So here is the overall premise. We're going to use shapes, colors, and size as an analog for type of number, base, system potentially, and resolution. So let's take a look. And I've kind of already given you a little bit here, but imagine that all you have is squares or rectangles, playing cards, for example, that only have two colors. And you have a fixed amount of space. So that'll be key for the extension here, but you have a fixed amount of space. So I picked 49 blocks as your limit, just because that works out nicely. 7x7 grid. You can start making some interesting shapes with that, but it doesn't get too overwhelming. If you try to go smaller than that, I mean, you can. You'll have to constrain maybe the types of things that you start representing. But so you have your input, you have your things that you can play with, which are the cards or these squares that you've created. And then for this I picked one shape, but really and you could try this one, or you can pick something else if you want. That won't matter. So I want you to create a picture of something, and you're going to create that picture over and over again with different constraints. So the first time, let's just create a house. So take your playing cards, take your set of squares. You can draw this out, right? You can do this on pen and paper. You can do this in technology if you want to. It really doesn't matter. But basically stay within the constraints. Use some squares, a finite number of them, that have two colors, and create an image. Then what I want you to do is to convert that picture into a sequence of either letters and or numbers, whichever you want. And then create an algorithm for someone to recreate your image from that sequence of either letters or numbers. If you have time, if you are in one of the synchronous rooms, or just whatever, if you're doing this later, try to compare your algorithm with somebody else's algorithm. So others are doing the exact same task. Did they choose the same number sequence or letter sequence? How did they do it? What is about the algorithm? There are different ways that you could translate this picture. I could think of a handful of ways to do it. At least right off the bat, 3 ways. And I mean, really depending on how you want to go through it. And there are way more than 3, by the way. I think you could come up with many, many different ways. So, but the question is, should you have discussed your algorithm beforehand with others? Maybe coming up with a unified way or approach of doing this. Not necessarily a requirement, but do you think, what advantages, disadvantages are there of doing it that way? All right. So that's part 1 of what I want you to do. Basically, create your image here with this fixed size square, rectangle, whatever. Next up, what happens if you take the exact same overall size, right? So you can't change that, but you were to cut your squares into smaller squares. So what happens to your total number of squares? What about what happens to the resulting image? What can you do now? Is your image different in some way? What are the implications of doing this to both say, well, all the steps beforehand? Okay, so maybe now, maybe cutting them into smaller squares caused some issues, who knows? But what happens if you, instead of cutting them into smaller squares, instead of just having 2 color options, you had 10 color options? Now, I'll save you a little bit of effort here, but if you're going to do 10 color options, don't start numbering at 1 because you'll run out of available numbers. So that's a hint for you. But yeah, or if you we'll leave it at that for now. All right. What happens if you try to combine steps 5 and 6? How many total options do you have? What are the implications of that? How do you record that information? Okay, of both color and this smaller size square. Okay, now step 8 here. Instead of squares, imagine that I give you triangles instead. How does that change everything we've talked about? Does it cause other issues? And then finally, on number 9, I'll leave you with, do you think you could introduce multiple shapes? All right, and remember, all of this, if you go up to the top here, oops, our original goal here was we have shape, color, and size, all to represent essentially type, base, and system. So you can imagine that the square could be an analogy for whole numbers, or maybe integers. Maybe integers is better there. And maybe a triangle might be something that allows a little bit more precision. The base is representative of color, right? When you have only 2 color choices, that aligns very well to how computers work on a 0-1 binary system, versus our colors of 0 to 9 are well represented in base 10. And then finally, the size could be your resolution, right? The more shapes you have, the much smaller your size is, the higher your resolution, right? The better the image that comes out. All right, I will leave you with that. And if you have questions, please ask away in any of the formats that are available. Thank you.